Good day everyone. So today we're going to talk about pre-calculus, the analytic geometry for grade 11 curriculum. First, here are the different learning competencies that we're going to discuss. Illustrate the different types of conic sections, parabola, ellipse, circle, hyperbola, and degenerated cases. Define a circle and determine the standard form of equation of a circle. First, let's illustrate the different types of conic sections, parabola, ellipse, circle, hyperbola, and degenerate cases. We introduce the conic section, a particular class of curves which oftentimes appear in nature and which have applications in other fields. One of the first shapes we learned, which is the circle, is a conic. When you draw a ball, the trajectory it takes is a parabola. The orbit taken by each planet around the sun is an ellipse. Properties of hyperbolas have been used in the design of certain telescopes and navigation systems. We will discuss circles in this lesson, leaving parabolas, ellipses, and hyperbolas for subsequent lessons. To define a circle, so when the plane is horizontal, an ellipse when the tilted plane intersects only one cone to form a bounded curve. Parabola when the plane intersects only one cone to form an unbounded curve. Hyperbola when the plane, not necessarily vertical, intersects both cones to form two unbounded curves, each called a branch of hyperbola. So as you can see in figure 1.1, at the bottom part, we have the circle. Okay, the plane is horizontal. How about for this part, we have the ellipse. So the plane is being tilted. For figure 1.2, it is the parabola. And for figure 1.3, we have the hyperbola. So the plane cuts the two cones to form a hyperbola. Next. The other ways for a plane and other cones to intersect to form what we are referred to as degenerate conics. A point, we have here figure 1.4, a point. A line, we have figure 1.5. And we have, for figure 1.6, we have two lines. So these are examples of degenerate conics. As you can see in the figure, the black boundaries of the colored regions are conic sections. So we have the circle, ellipse, parabola, and hyperbola. Let's now define a circle. A circle may also be considered a special kind of ellipse. For special case, when the tilted plane is horizontal, as you have seen in the figure 1.1. As we get to know more about a circle, we will also be able to distinguish between these two conics. This is the illustration of our circle. So let's see B a given point. The set of all points P having the same distance from C is called a circle. The point C is called the center of a circle, and the common distance is what we call the radius. We have here the segment PC, which is our radius, also with BC, another radius, and we have CA, AC for radius. The distance from the center on the circle to the point on the circle, we have 5. So that is the radius. For the ordered pairs, we have for the center, we have 3 and 1. And then points on the circle with the distance of 5 units. So we have for point B, we have 6, 5. And for point A, we have -2, 1. This is the standard equation of a circle with center C, H, K, and radius is represented as R. If the center is the origin, then our H is equal to 0 and K is equal to 0. The standard equation is written in the form of x squared plus y squared is equal to r squared. We have also the standard equation of a circle in a vertex form. We have x minus h squared plus the quantity y minus k squared is equal to r squared. Okay? So, if the point is located at the center, the standard equation of a circle is x squared plus y squared is equal to r squared. But if the circle is located on a quadrant, we will use the standard equation of a circle in a vertex form to easily identify the vertex or the center of the circle, center of and radius of a circle. Let's now identify the center and radius of a circle having this equation. 4 times the quantity x plus 3 squared plus 4 times the quantity y minus 0 squared is equal to 16. First, we are going to divide both sides by 4. You have to divide it both sides by 4. So 4 divided by 4, 4 times the quantity x plus 3 squared rather divided by 4 is x plus 3 squared plus 4 times the quantity y minus 0 squared divided by 4 is y minus 0, the quantity squared. 16 divided by 4 is equal to 4. After that, it is already written in the form of the vertex form of a circle, but in the value of our 4 is still written in r squared. And we need to identify what is the value of our r. So finding for the roots of 4, we have 2 squared. To identify the center of a circle, we have here 3, negative 3, and then 0. So this will become, why is it negative 3? The original equation of our vertex form is x minus h. Since it is positive, so negative times negative is positive. Therefore, our h is negative 3. How about for the second equation? We have here 3x squared plus 3y squared minus 6x plus 9y minus 14 is equal to 0. First, you need to regroup having the same variable. Okay, so we have 3x squared minus 6x plus the quantity 3y squared plus 9y is equal to 14. And then after that, you're going to complete the trinomial so that you can factor and have a perfect square binomial. Next, but before that, we have to factor out first the two terms. Since 3 and 6 have a common factor, which is 3, so we have to factor. So 3 times the quantity x squared minus 2x. The same with y, which has a common factor of 3. So 3 times the quantity y squared plus 3y is equal to 14. After that, you have to divide it both sides of the equation by 3. The result now is x squared minus 2x plus y squared plus 3y is equal to 14 over 3. To complete the perfect square trinomial, so we have here, how did you get 1? So the second term must be divided into 2 and then square it. So 2 divided by 2 is 1, then 1 is square is still 1. The same with the idea of the y variable, you have to divide it by 2 and then after that you have to square to get the third term. What have you added on the trinomial must be added also with the constant to the left side of the equation. So 14 over 3 plus 1, which is based from the variable x, and then a 9 over 4 for the y. The result now, so let's factor first the trinomial x squared minus 2x plus 1. The result is x minus 1 squared. Factor also y squared plus 3y plus 9 over 4. The result is y plus 3 halves squared is equal to, so since our 95, the result of 14 over 3 plus 1 and 9 over 4 is 95 over 12. Okay, so find for the root since it is still equal to r squared. Okay, so I have to erase that one. So r squared. Our 95 over 12 is still in r squared. So to get is we have to find the root. So square root of 95 over 12. Square root of 12. Okay, find for the values that has a perfect square. So square root of 95, and then 12 has a factor of a square, that is 4 and 3. So that will become square root of 95 over 2 square root of 3. For the center of the circle, we have 1 and negative 3 halves. And for the radius, we have square root of 95 over 2 square root of 3. So that's for the lesson today. So goodbye and thank you.